Alright, we're streaming. Ooh, wow, my keyboard is really squeaky. Adjusting things, streaming, basic, Unreal stuff. Paste. Well, I strained my voice and didn't get much sleep, but we'll try and do some UI stuff. This UI stuff is probably incredibly boring to watch, so, you know, it's one of those things where it would be better if I could move on to something else, but I don't know how this UI stuff works, so I've got to build it. Now what we're going to do today is we're not going to do dragging and dropping anymore. I've created some very, very basic placeholder images, so we're going to look at pure squares. But at the end of the day, we still have these problems here. These are the drag and drop approach that we tried to get to work, and it's not worth it. It may be possible to get it to work. I'm sure it is possible because I think we have access to the source code if we really want to get our feet wet. But it's clear that the eventing system for the mouse in the UI isn't set up to do any of the things we needed to do. So the way we would actually do a drag and drop system is we would have like a universal background layer that intercepted all mouse motions, and then manually handle every single motion of the mouse rather than using their built-in event system, since their built-in event system works for shit for what I wanted to do. But we can do the same thing with buttons, so we're going to build us some buttons. Now, the first thing we're going to need is a widget blueprint, which we're going to call a chip. I know I just deleted one called chip. In fact, oh, okay, so it's it can't share the same name as an image texture? That's odd. We'll call it WChip. The image is not the same kind of asset, so I don't know why it would need to have a unique identifier like that, because this is like, well, whatever. No, really what you would do is you just wouldn't put the image files in the same place as the frickin' code. Whatever. We'll just throw it all together for the moment. We'll figure it out later. So here we've got this canvas panel, and we're going to delete that. We're going to try using a size box. I'm not actually sure whether the size box is of any use, but we'll try it. And because my placeholder image is 128 pixels, we'll go ahead and use 128 pixels. Then we'll drop in the image. Pachow. And as you might expect, it is going to be 128 pixels. It should just be called chip, right? There it is. And you can see that it is a wonderfully not at all even vaguely 128 pixel setup. So we'll just do it like this. And that's going to be the chip, but we also need to add in the buttons that we're going to want to click. Only problem is I think the size box actually only allows for a single child. Let's take a look. Yeah, so we can't use the size box. The size box was a bad idea. I'm trying to remember what else there was. Canvas panels? I think it was the canvas panel that we actually wanted. So we're going to go ahead and copy this and then delete the whole thing. Drop in the canvas panel. Drop in the canvas panel. And then can we... Is this not what I want? The problem is, oh, there it is. I was just zoomed in too far. That's fine. And there's our image, and you can see that our image is absolutely not even vaguely set up correctly. There we go. Another reason we're orienting it like this up here is because we're going to have like 30 or 40 of them scattered all around a movable background frame. So the widget needs to be zeroed out. The only problem is that there is a glitch, or I'm not even sure if it's a glitch, a miss feature where the outline shows up incorrectly, and I think that means I think that was the source of our problems with our drag and drop. There was some kind of offset problem, but we're not doing offsets, we're not doing dragging and dropping, we're just doing buttons, so we should be okay. So what we're going to want is a series of buttons. No, that's not it. All right, so once again, we're going to break the alignment into the correct area there. And we're going to put it at 100 off. That should do for now. We'll fix it later, change it later as we want. Now this button is going to be copied and pasted. And for some reason, the first button is named button 219, and the other buttons are named button 0, button 1, and button 2. Brilliant, as you all know, one of the core tenets of any sort of interface is that the naming convention has to make as little sense as possible. All right, so in theory, this should work. We're going to go ahead and pop up the HUD. Now the HUD exists from before, and it just is in the scene automatically, and it's got a graph that spawns in a... or it doesn't? This is odd. I thought that the HUD was responsible for spawning in the chip. Oh, that's right. It's not a spawning thing. It's just a dropping in thing. There we are. It's just here. It has nothing to do with the graph. So in order to do that, we're going to add in a chip. Just drop it in somewhere. Now, as you can see, it is sized very clearly to the content at 1 pixel by 1 pixel. This nonsense can be fixed by hitting play and then hitting stop. And hey, look, there it is. It actually imported. Beautiful, right? So here's what I was talking about. You can see that this box that we've got here is sized appropriately, but it is offset because this is the framing box, right? And I'm thinking that this was what was interfering with our dragging and dropping. But it doesn't really matter. The only thing that really matters at this point is whether we can click on the buttons. So if we hit play and then click on the buttons, you can see that we can click on them. So that's good enough. So now what we've got to do is we've got to make the arrow, and we've got to make it so the arrow moves in the direction that the button is clicked. Now there's a couple of ways to do that. We can have the arrow be its own widget on top of this, or we could have the arrow be part of this as an image box that moves around on its own. But if we do that, it's going to be very difficult to actually move it because the UI elements inside of things like canvas panels don't like moving. So we are going to, in fact, create a new widget for the arrow. Here it is. Now all we really have to do for this is create a widget that is the same offset as the button. And the button was 100 pixels down, so when we create something here, we're going to have it 100 pixels down. In this case, we are once again going to use that same layout panel. There it is, canvas panel. Just drop that in. And then we are going to put in an image. Drop that in. And this image is obviously going to be 64 pixels and the image of the arrow. So that should be fine, but of course it's not set up quite right just yet. There we are. Now it's set up correctly. Actually, it should be like this. Why not? So now we have this image here as offset from the center in the same amount as the buttons that we had. So what we can do now is we can have that get spawned inside of this array. Now I don't believe, can we just add an arrow? We can. So let's just go ahead and add an arrow. We'll put it at 0, 0, and then just size to contents. I don't see it. But as before, that might be because I have to hit play first. I don't see it. And it could be just because it's behind rather than in front. Oh, this is on the HUD. We actually don't want it on the HUD. We want it on the chip. I have these things in an order I didn't expect, and that's why I got all confused. So that's the thing. I don't know whether or not I can add the arrow to this. Let's find out. Yeah, it seems like I can. Oh, that's interesting. I can kind of add it. Oh, I see what's doing there. It's just kind of snapping to the button, so it would be a child of the button if we did it like that. So, yeah, I think that's correct. There we go. Now, if we compile that, save that, check it out, press play, you can see that now we can't click on that button anymore. We can click on the other buttons, but clicking on this button actually starts up a drag and drop operation for reasons that are unknown to me. So we'll have to figure out why that happens, because I don't want that to happen, but we'll figure that out eventually. Let's just check HUD, make sure there's no yeah, there's no overridden functions for that, so I'm not sure why it thinks it can drag drop. I'm assuming it's drag drop because it's got that little plus when you click. These are the sorts of things you got to pay attention to, because otherwise you might get blinded and, you know, oh, I didn't expect that. So you see how this is an arrowhead, and as I click on it, it remains an arrow. When I move over here, it's an arrowhead, and when I click on it, it turns into a plus. Now that normally means that you're trying to draw a selection box or doing some other kind of drag drop operation. There is no operation that can be done to the image, so I don't know why it is turning into a plus. It does seem to happen on any image, not just the one for the arrow. I'm not sure what's going on there. We'll have to figure it out later, I suppose. So for now, what we're going to want to do is pop up. What happened? Did I close it? I must have closed it. Not the most brilliant person here. Maybe I shrunk it. So what we're going to want to do is these buttons, each of them is going to have to be treated differently. So let's go ahead and name them. That way we'll know which direction it is, because when we go into the graph, we're going to have to respond to those clicks individually. I'm not 100% sure how to do that. Like, there's got to be an on click, right? Assign on clicked. This doesn't seem right. Set click method. That's definitely not it. So there's got to be a way to do this that doesn't require us to assign them at runtime, right? Like if I were to select the button here and look over on the right, would there be a click behavior? Events, here it is. So we can hit this, and you can see how that just adds the on-click to B east, and we're going to need to do that for each of them. B south. Oh, I can do it here too. East, south, north, and west. There we are. So now that we've got these on clicks, we can now have them move the value, the rotation value of the arrow, because the arrow is centered around the center of our image. So if we just change the rotation, it'll spin around like a dial. So to do that, we're going to want this arrow to understand what rotation it should be at. And now I don't know whether it would be better to tell the arrow that, or to have this tell the arrow the rotation it's supposed to be at. Let's take a look. I don't know how to set the rotation. So if we take a look at this arrow, I was assuming that what we could do is just set the rotation here, but I'm not 100% sure that rotation is something that exists. Let's do a quick little search. Unreal UI rotate. How to rotate an image in the widget. Render transform. Okay, so I've got to set the render transform. Here it is, set render transform angle. So basically what we're going to want to do is we're going to want to have a variable here for target arrow angle, which is going to be a float. And we're just going to have this so that every tick we move the target towards the angle. I don't know, can we get the render transform angle? Yeah, there we are. So what we're going to want to do is lerp towards the final property that we've got. So we get the return value from the current value is like 0 or 86.3, and then we have the target value here, and then we want to not lerp between them, we want to move towards. Do we have a move towards? No. I mean, we could do a lerp. It's not against the rules. I just don't want it. It's not the right it's not the right sort of response. I want to move towards rather than a lerp. Whatever, it's fine. We'll just use this for now. And then obviously we will pass it in the delta time. We may change that to a large multiple of the delta time or something like that. It's not important at the moment though. So basically, that's what we want. Every tick, we will move it towards the target, and for these, all we need to do is set the target. Now, I don't know whether or not these are angles. I don't know whether this is a degrees or not. We'll know for sure in a minute here, because what we're going to do is we're going to set this based on which button gets clicked, and we're just going to assume that it's in degrees for starters. And obviously, if it's not, easy enough to fix, not a huge deal. Come on, the 1 pixel where it's allowed to actually connect. Now the only issue I've got with this is that even if it does work, it's actually going to go the long way around if you go from north to east, but that's like not a huge deal. We're not too concerned about that at the moment. All right. Save that, compile that, shrink this down, hit play, and click. Ooh. Well, good news, it's in angles. Bad news, it is absolutely not rotating around the anchor point. I don't know what it's rotating around. It's rotating around this corner, sort of, but it's not. It's rotating around like slightly offset from that corner. This is something I found happens a lot in Unreal's UI, where it will anchor on an edge, like at random, and it's like, what is it about that particular edge that makes you think that's the right place to be anchored? I specifically set this up to be anchored around 0, 0, 0. That's like legit the whole reason why I set this shit up the way I set it up. Look, anchor 0, 0, 0, and here it is. All I can think of is that the canvas panel is not doing what I thought it was going to do. Like, do I want to change this to 0, 0 instead of 0.5, 0.5? I can't imagine that's going to help, but we'll go ahead and give it a shot. No, that changed literally nothing. So here is the widget itself. What if I changed it here in the widget itself? Literally nothing. So my thinking is that maybe it's ignoring the widget and the panel and it's rotating the image on its own, and like the image's internal anchor is set up a little funny. Let's find out. We can open up the image. Here it is. Brightness, vibrance, hue, file path, compositing. There's no like transforms here. There's no way to set the anchor point of the image specially. So I don't think that it's caring about this image as a specific thing. For some reason, it thinks that the center that it should be rotating around is here. That doesn't make any sense. Where is it getting this point? Right there. That's... I mean, I was thinking maybe this isn't 0.5. Maybe this is some kind of like pixel offset or something. Let's go ahead and change it and see what happens. Nothing. It's exactly the same. So this has nothing to do with the W arrow widget. There's nothing there that's doing any of this stuff. This is something that's happening inside of the chip. So on the event tick, we find the W arrow, we get the render transform angle, and then we set the render transform angle. So my assumption here is that the render transform is not properly adhering to the geometry of the subwidget in the same way that I would expect. My assumption here is that there is a transform that is radically different than I would expect. And now the way to get out of that, maybe, is let's go ahead and add like a physical thing. So if we were to add another image here, and we were to move it up, and then we were to make this like an unavoidable thing, like this. Let's see whether or not that changes what part of this image we rotate around. No, okay. What the fuck's going on? This is like deeply weird to me. I have no idea why it thinks that that is the location it should be rotating around. All right, so the other option here is, let's put it at 0, 0, 0. Huh. Okay, so clearly the render transform is doing something a little strange. This is not rotating the image around its alignment. It's just not. This render transform is not what I would expect. So let's see what sort of other options, like, can we pivot, set render transform pivot? Do you think maybe this pivot is the problem? All right, so Now this is definitely not going to work. This is going to screw up. But the question is, in what way will it screw up? Oh, look, it didn't screw up. Okay, so the problem was that the pivot wasn't in the right spot. There's something there that was changing the pivot. Even though you specify the pivot manually, right here, there was something about it that was replacing that manual pivot set. So we're going to try it again and see whether or not that fixes things. Ah, there we go. So for some reason, it was just getting a garbage pivot. Now here comes the part that's not so great. Whoa! Now there is a way around that. The way around that is to move towards 360 instead of towards 0, or something similar, right? But I don't really want to deal with that right now. I think we can go ahead and leave that as is for the moment. Now, the problem with this approach is that there are, in fact, 2 out arrows. There is the successful out arrow and the failure out arrow. Not every chip has 2 exit conditions, right? Most chips only have 1 exit condition. So this would be a sort of exit chip that you would expect to see most of the time. But for like an if statement, or say if you're scanning, like, do you detect a robot over there? There would be a yes and a no answer. So that means that what we really want here is not 4 buttons, but 8 buttons. So that's what we're going to do now. We're going to go ahead and fix this up to be a little bit more in line with what we want it to be like. Over here, I have this. And what we're going to do is we're just going to resize this arrow so that it is half the height. But I have to think about how to do this. Change image resolution. Don't lock it. I hope it's not locked. It's locked. God damn it. Change image resolution. Where's the fucking lock? Okay. Interesting. I thought I knew this program inside and out. I'm not sure why it decided that image resolution absolutely needed to be locked. I don't remember this ever being the case. What a fucking annoying piece of shit. Okay, well, we'll change the canvas size, 32, and then we will manually scale down the actual size of the layer. Let's just Control T, I guess. Control Shift T. This really shouldn't be... I'm sure that I'm just missing something, and if I wasn't streaming, it would be obvious. But unfortunately, I am streaming, and it is not obvious. Okay. Save that. And then we'll go ahead and repaint it for the other half. This is all just temporary, obviously, so it's not that big a deal. Arrow no. And we'll rename the other one arrow yes. All right. No, I just saved over both. God damn it. This is the hard thing about streaming. Streaming makes you not very bright. Like your brain just shuts off. It's how it works. I don't know why that is. It just is. All right. Just force delete it, I guess. I don't care. Nothing that I'm doing here is significant enough to matter. All right, so here we've got the arrow again. We're going to need to have an arrow yes and an arrow no separate set of classes. And to that extent, we're going to want to rename this one arrow yes. That's a yay. And we'll just Open that up. And we're going to be replacing this image here with arrow, yeah. But we're going to move it up some so it's like negative 20. Maybe even more, negative 28. Now the reason we're doing that is because we're actually going to be passing variables from the chips to the chip's neighbors. So what I'm thinking is, if the chip is here, we'll have an out arrow and another out arrow, and they'll be separated from each other like tuning fork bands, right? And then in the middle, you can have the variable pulse. Like, oh, you got a variable that just triggered. We can shoot that down or out into various directions. And hopefully that will allow it to feel right. Arrow, yes. Save that. And then we're going to want to duplicate it. Arrow, yes, too. No, arrow, no. Pop that up. Here we go. We're just going to take this, yes. Boom, like that. And it's now a no. Boom. Perfect. And now, of course, we are going to open up the chip. Here it is. And we're going to replace these buttons with more distinct buttons. So you can see that we've got this, and it's no longer of any value. We'll just go ahead and delete them for the moment. And we're going to want all of these buttons to change their size and position. So that's going to be, was it negative 28, I believe I said? It doesn't really matter. I can fix it later. But of course, the challenge here is that we have to make sure that these are all correctly labeled. Why did it pop in? Oh, okay, whatever. And this is going to be yes, no. Be no east, be yes east. So here's the question. If I were to delete these bad boys here, could I copy these two? I don't think I can. It's not letting me duplicate copy. Ah, okay, wow, that's not easy. So then what we need to do is, I guess rotating them isn't going to work, is it? I don't see any option to there's no option to rotate. It's just wiggle and wobble. So I guess we're just going to put these over here, negative 100, and we are going to rename them to no west and yes west. And we will once again paste. They really make it difficult to do this. Like the setup is not ideal. And then obviously we're gonna make this 32 by 64. I guess we'll just delete you. And that's going to be 100. And was it 28? Is that correct? Yes. So this is going to be yes south. Copy and paste. Pops up in the middle of nowhere. And that's going to be no south. And then we copy them, and then we paste them, move them up. And just nudge them a little. That's interesting. How did they end up at 24? Are these in the wrong spot? No, that's strange. Well, either way, we have to rename them. So this is no north. And this is yes north. All right. Now, obviously, we're also going to have to do some graph nonsense here. We've got this, and we're going to need another copy. This one is going to be named arrow yes angle, and then down here we'll have arrow no angle. I don't know why I'm using underscores. I guess I'm using underscores because I did a little bit of Blender, and Blender really aggressively uses them. Float. We're also going to want a Boolean for whether or not there is a no arrow. Boop. We'll go ahead and make that default to true. No arrow exists. Yes. That's a strange way to put it, because what we mean is the no arrow, rather than there is no arrow. That's fine, though. So we can see there's a lot of these warnings that are all screwed up. We're going to just want to fix everything. We're going to want to set everything up to be nice and clean, and then, you know, duplicate it all and make sure that it's all working fine. These no arrows are the same setup. Get no arrow. Tom Baum says, what code language? I'm using Unreal, and this is just Unreal's blueprints system. If I was going to use Unreal's actual code, it would be C++. This, however, is not something that requires code. I'm not too worried about it. I just have to understand what's going on with Unreal under the hood in terms of how their UI transforms work. All right, so let's go ahead and start to work with some of these here. So here is the no east, which is the 90, or rather than nothing, it's this guy. Unclicked no north would be 270. No, that's not what I want. Can I drag it in? No, I've got to let it pop it up in a weird spot. And then we've got no south, which is 90. And then we've got no west, which is 180. Now we've got the yeses, same basic things. Can I select all of them? I cannot. Okay. So here's the yes east. You know what? Because it's popping them up down there for reasons that I don't understand, we'll just move our shit down there. Yes east. Yes north. Oh, moved it down. Okay, so it just always pops it up in the least useful place possible. They've actually created their algorithm specifically to do that. Brilliant. Brilliant. And yes, west. There you go. The only other thing we have to do now is this here. We just have to do the exact same shit, but, oh, you know what? There is the reason this is busted is because there's no longer a thing named what we were originally changing, so that it's now disconnected. That's okay. We're going to reconnect it. Just get this arrow, put it here, and once again, that's going to be the delta time down here. And the targets for these things are going to be the new yes arrow and no arrow. What? Why is this? Oh, those are the floats. My bad. Let's go back out into the designer. I forgot to actually import them. Okay. I was wondering why they didn't exist. They didn't exist because I didn't put them in. So we're going to just put in an arrow yes and an arrow no. And we are going to set those up at 0, 0, 0 with the size that they want to be. It's going to completely barf out and screw up, which is fine. We will just hit the play button and it should snap right into place like magic. You can see that. We got the green and the blue, or the blue and the orange rather. And what we're going to want to do is over here in our graph, we are now going to use those values. Those go here and here. And this goes here and here. And if we wanted to make that look a little bit more clean, what we would do is just add a little routing node to it so that it doesn't have quite the same amount of garbage. And of course, the last thing we need to do is actually plug it in. Yonk. So we'll just save that, compile that, and see whether it works. The lerp is no good. I really need to move towards rather than a lerp. I guess I could write a custom function for it, but I mean, every language on the planet should have a move towards. It's just a basic math function. Maybe they just call it something else. Let's go down into math. Math. Float. Finterp. That might be pretty good, actually. Fixed turn. Is this? No. Increment float. That's interesting. In range. Lerp, log, make literal, make pulsating. Oh, that's interesting. Map range. Max of float, min multiply by pi, nearly equal. Power, round, safe divide, snap to grid, square root, truncate. Okay, so it doesn't exist. But lerp isn't in here either. Oh, there it is. Okay, so we may have to make our own function for this, which is pretty stupid, but that's okay. We're going to go ahead and make a new function, which we're going to call value towards. And it's going to take in a couple of values. It's going to take in a float, which is going to be called delta time. And it's going to take in a float called current value. And it's going to take in a float called target value. And we are going to make it so that it magic wraps, because we're only going to be using it here, so we might as well. And the way this is going to work is we are going to simply move it by up to the delta time value. And if we change we'll multiply the delta time by some amount. And that's going to allow us, that can be pure. That's going to allow us to move by whatever amount we want. So to do that, we are going to have a switch based on whether or not the target value is greater than the current value. But there is a piece to this switch which is a little bit different than you might expect. If our current value is greater than or equal to 270 and our target value is 0, we're going to want our target value to be 360. So the first thing we need to check is whether or not our target value is 0 and our current value is 270 or higher. Yeah, we're going to want greater than or equal to. And so if our target value is, if our current value is greater than or equal to 270, and our target value is equal to 0, then we are going to substitute in the target value of 360. So to do that, we will simply have to have a switch here, a float switch, I believe they call it. Switch on eFloat types. No, it's the opposite of that. What is it? It's not a switch. It's a chooser. Flip-flop. I still don't have this shit memorized. Unreal uses very specific terms. Is it not a switch? I could swear it's a switch, but it's not a switch on. It's a switch for, right? It's not a branch, because the branch is for code execution. Yeah, so it's not the branch, it's the switch box. Switch. Let's just go ahead and take a look at this here. Unreal blueprint 2 float values bool. Choose between 2 values in a function. God, they're telling us to use the exec pin. I think this is someone who doesn't know what the fuck they're talking about. Select. It's called a select. There it is. Ugh. I'll remember it someday, but today is not that day. So if we're going to be doing that, then what we're going to be doing is having our target value, or I guess our target value will be the B slot. The A slot is, what's this B? Why is this here? Target value B. The A slot, oh, God damn it. Do I have to actually delete a variable that just got randomly created? Why is this here? How do I delete it? I don't want this. How do I... Okay, undo, 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 undo. All right, I don't know what the heck happened. There we are. Let's go ahead and try and set this up to feel a little bit nicer, because it's a little confused at the moment. So to do that, we'll just put in some routing nodes. So that will give us a final value for the target. So that just means that we won't do any more spinning, right? And so what we're going to do here is we're going to want to have this delta time get multiplied by a specific thing. Multiply. For now, we'll just say multiply by 90. No, let's make it multiply by 180. Because that's degrees per second is what that is. And then we are going to say that if the value is, if the current value is less than the target value, we need to add to it. Otherwise, we need to subtract from it, right? So if the current value is greater than, the target value, then we're going to want to invert this pin. So I guess what we would do there is we could use another select float. Why not? And we'll just make this, we're going to have 180 and 180. Now, all that we're really doing here is setting this up with a whole bunch of logic that would be very, very easy to do in C++. And this is not really what blueprints are any good at. I'm not sure why I'm insisting on doing it in blueprints, but apparently I am. So that's what we're going to keep doing. We're going to just try and make it work. So we now have a delta value, which we can add to our current value. So we're just going to add, and we're going to pull in our current value here. So like that. So that's delta time. My bad. That's not what I wanted it to be. I made a mistake there. I need the current value, which is here. Maybe it would be better if I just pulled it in straight instead. Well, that's fine. Let's go ahead and back it off a little bit. I wish I could change. It doesn't matter. It doesn't matter. None of this matters. So we basically just add it together. And then once we've added it, what we want to do is we want to make sure that it is clamped properly. So that means that if it was greater than, we want to clamp it so that it's not going below. And if it's less than, we want to clamp it so it's not going above. So to do that, we can use, I believe there's going to be a clamp function. Here it is. And so what we're going to want to do is we're going to want to set the minimum and maximum to values that make sense for us. So, you know, obviously this would be the value that you'd use, but what we actually want to do is set those values to the target value based on whether or not they are true. So we're going to have this either be 0, which is the lowest it can go, or we're going to have it be the target value. So that'll be this guy here. No, god damn it. And similarly, it's going to either be 360, that's 36,000, or the target value. The only issue here is that I may actually be ending up making this backwards, so I'll have to, you know, change those. But those are the basic idea here. So that's how it's going to work. However, this pick A is probably not going to be correct. So let's go ahead and figure out what that should actually be. So if the current value is greater than the target value, then we want the target value to be here. So this is going to be the minimum. So if it's greater than, we set the minimum correctly. If it's less than, we set the maximum correctly. See that? So that should work. And then we're just going to be clamping it down like so. And that's going to be what we return. So let's go ahead and set up a return for this. Needs a float. We're going to call this value. And where did it get put? Oh, it's way the heck back there. That's fine. This is so much uglier than it would be in code, but it should work. The only problem with this is the 360 thing. So right now, we move it towards 360, but once we get to 360, we never actually set it back to 0. So what we're going to want to do here is a special case where if it exceeds or matches 360, we want it to become 0. So we're going to do equals 360. And then if it does equal 360, we actually want to do another switch. Select, my bad, select. Where we pass it a 0 or this value. And that'll create the nice wrap that we need to have. So I believe that there are like comment boxes and stuff that we can add, but I'm not going to bother in this case. We're just going to see if that works. We're going to pass this back out to the main graph here. Event graph, here it is. And you can see that we've got these lerps, and these lerps are going to go the way of the dodo. We are instead going to use this value towards. So with the value towards, we're going to want the delta time. Can we get the delta time? This is the same value that you could get here, but it's just closer so that we don't have to drag lines everywhere. and the current value, and this target value. Oh no, wait, that's set up like this. There we go. So we're just going to arrange this nice and pretty. We'll just copy this and paste it. There we go. And we will just substitute in these pieces where they're needed. No, stop that. Why did you delete the wrong thing? Yoop. Pachow. There we go. Let's find out if that works. Oh, I got a fly in here. Whoop. 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 Oh, look at that. Works fine. Now, I want to change the buttons so that I can tell which buttons are yes and which buttons are no. This is like just doing basic stuff here. It's not... This is nothing like, oh, look at the cool shit he's doing. I'm not doing any cool shit. If you are hoping for cool shit, I'm sorry, you're going to have to come back some other day. But for now, we're going to change the colors here. Now, it says that the color is white. It absolutely is not. It is there. The most dim, dismal color imaginable. There, this is the tint. So this is the yes. So we're going to go ahead and make it a vibrant blue. And then for the nose, we are going to make them a orangey red. And we'll have a lot of opportunities to figure out, better ways to do this. For example, we might change the buttons so that the yes button is in a different place or something like that. I just wanted to make sure I could do this because I was, being like, oh, this would be, I wanted to do it with drag and drop, but this would be so easy if it was not drag and drop, if it was just, clicking buttons. And I was like, it's definitely going to be easy, but I thought drag and drop would be easy. So I had to try it, and it is. This is not... Of course, it doesn't go the other way yet because I don't have the opposite bit there. I could do like a modulus or something. It doesn't matter. Anyway, the point is that we now have a setup where we can set these chips to pointing in any direction we want. Now, what we would really want to do ideally is have this chip understand the direction that is being pointed on a level other than angles. Right now, we set it up as an angle. What we really want to do is set it up as an enum so that we know which way to pass the code. But we're nowhere near needing that. I was just trying to get used to the basic setup here. If we pop up the HUD, here it is. Let's go ahead and put in another W chip. And you can see that the offset's not quite the same. So we could use like a grid. Let's try that out. Let's see if we can get ourselves a grid, because I know that there is a grid. A grid panel, a uniform grid panel. Let's try that. Uniform grid panel. Canvas panel's gone. Uniform grid panel is here. And then we can add in the chip. Chow. And chip it up. And you can see that the grid panel is not doing anything correctly. Let's see what we can get here. 200 and 200. Okay, I'm not sure what's going on. Let's see whether or not it will magically work once we hit play. It does not. Okay. So this grid system does not do what I hoped it would. A panel that evenly divides up available space between all of its children. Does it think that there's no available space? Is that what's going on here? So is the uniform grid panel supposed to be on top? It's supposed to be below a canvas panel or something? Must be. It must be that the uniform grid panel is supposed to be inside of another panel. Let's try it. So now you can see that the uniform grid panel has a specific size, and that specific size is very tiny, and we can make it whatever size we want. This is how it's supposed to be. All right, so we're just going to make this like this, put it over here somewhere, and then we can drop some chips in. Now we're going to want the grid panel to have specific preferred sizes for reasons that we'll get into later. Where is the specific preferred size? Did we or did we not have a specific preferred size? Oh, this is the wrong grid panel. So here's the uniform grid panel. And with the uniform grid panel, we can set it with a specific set of preferred sizes. Where did that go? Here it is. Now the reason for that is because we actually want these chips to overlap. Not much, but some. So that's the idea. Now, in all earnestness, what we may end up doing is making a full 3D version of this, because the UI stuff is bonkers terrible, just the worst. And it might make more sense if we just did everything in 3D. All right, so it looks like... Okay. So we actually have to set up where on the grid they're going to be. That's interesting. I would have thought it would have just filled it out, but that's fine. I can live with that. But you can see that it's not quite dense enough yet. There. That's the kind of density we want. Obviously, this is not ideal yet. I just want to test it out and see what's up. So here you can see that as we move these around, we get slightly different responses. This is like just to try it out and make sure that I'm not losing my mind. I think it's pretty clear this is going to be better if we do it with full 3D. So that might be what we do next week or on Wednesday. The basic idea here is pretty simple. I'm trying to think about, if we're going full 3D, can we wrangle any other advantages out of it? Because it's basically just a grid, right? It's a grid where you put chips down and then you tell the code which way to flow out of those chips. If we do it in full 3D, then it would be possible to put chips in strange configurations, like on walls. But I'm not 100% sure that that's a good idea. I'm also not 100% sure it's a bad idea. There are some things about it that I like. The issue is that if we do that, then we have to allow for a camera that can actually do that shit. Like, we have to allow for a camera that can point in different directions. Whereas if we remain on a static grid, we don't have to worry about that so much. I think we'll stick with a static grid. Now, I wonder if I can pull off some kind of... See, if I'm going to 3D, I want it to feel like some kind of physical object rather than just a logical object. And I'm thinking about how we could make a grid-like situation feel more physical. Well, we'll think about it. We'll have to do that next week or on Wednesday. For now, I'm going to be done for the day. Thanks for stopping in. See you folks around.